Automation is the major driver of our modern economy because it allows individuals to be more productive than ever while using fewer resources. And as technology continues to reshape modern business, more and more tasks can now be automated. And automating processes doesn't have to be hard if you're using the right tools. And this is where Python comes in. Python is an easy-to-learn programming language that you can use to build automations. And because Python is the fastest growing programming language, new tools are being developed and added every day. In this course, I'll introduce you to some of the interesting ways Python can automate computer operations. We'll take a look at how to click and type on websites, interact with APIs, web scrape datasets, and automate file and terminal interactions, and more. By the end of this course, you'll understand the many ways Python can automate tasks and feel confident constructing these automations yourself. So, if you're excited about compiling your own army of automated robots, let's go ahead and get started. So what do you need to know prior to this course? Well, because this is an intro-level course, the requirements are virtually nothing. In general, it's good to have some basic understanding of Python and its syntax, file and directory paths, and basic terminal commands. Also, something to keep in mind, there are some files located in the exercise files folder that we'll be using during this course. Regarding your setup, all you'll need is Python installed on your system and any text editor or IDE that can run Python. So what's my setup? Well, throughout this course, I'll be using macOS along with Visual Studio Code to run the Python 3 scripts. Don't worry, you don't have to mimic this setup as the process for any OS and IDE will be virtually the same. Automating file, folder, and terminal interactions with Python is a valuable skill, whether you're a data scientist or just trying to optimize your workload. The inclusions of these skills gives added depth to your Python interactions because your scripts are no longer bound to themselves. For instance, writing files with Python is critical as datasets can now persist even after the program is finished running. Or perhaps you work with large directories that contain tons of files and file types. Automating terminal commands can give you the ability to instantly organize any messy directories into categorized subdirectories. In combination, these skills allow your Python scripts to fully automate many basic processes, while also giving them the outlet to preserve information even after their execution. So, make sure to download the exercise files as these will be used throughout this chapter. However, no external libraries are needed. File I/O is a fundamental of programming because it lets scripts not only create but also interact with external files. Today we'll be working with a short text file I've created, which I've named inputfile.txt. And you can find this in the exercise files for this course. It just contains some arbitrary data, but we can imagine it as a public survey where we tested individuals on whether they could pass a test. The columns represent their name, age, and whether or not they passed the test. P denotes pass and F denotes fail. Now that you're armed with some context, once your file is downloaded, move it into your working directory and let's get started. The first goal is to read the inputfile.txt. So reading files in Python is actually very simple and requires no outside libraries. To read a file, all we need to do is use the built-in function open and pass in two parameters, the file name and how we'd like to interact with that file. Let me show you what that looks like. In this instance, I use R as our script should read in this file. To check if we correctly read in the file, let's try printing the output. I'm going to simply type print f.read. Also, whenever we're done interacting with files, we should always remember to close them to prevent unforeseen consequences. With that, we're good to go. Let's try running our code. As you can see, we're now printing the entire file in terminal. Now that we can pull the entire file, let's imagine a trickier scenario. Instead of printing the entire file, we've been tasked with only printing the information of people who've passed the test. To do this, we need to iterate through the file line by line and check for each instance of the P or F tag. Let's start by replacing our print statement with a for loop that prints every line. To demonstrate that this loops line by line, let's add a counter and append it to the print statements. Now let's try running our code. As you can see, the counter is getting updated every iteration. Alright, so going back to our problem of only printing the info of people who passed, we now have the ability to iterate through the file by line. So the next step is is to check whether the standing for each person is a pass or fail. Looking back at the text document, we can see the pass or fail tag is nicely oriented as the third element in every line. To use this to our advantage, I'm going to split every line by white spaces using the .split function. Now we can check if the third element has the pass tag p. Let's also go ahead and remove our older code, as we no longer need it. To check if our code works, let's run it in terminal. Great, now we're only printing the information of people who've passed the test. So I'm all set up on reading files. Now it's time to check out how to write files. To demonstrate the flexibility of file writing, let's incorporate it into our existing code. Instead of printing the information to terminal, let's instead write it to a new file. Using the same open function we used to read files, let's now use it to write files. This line will create a new file called passfile.txt. Also notice how I'm using w as our second parameter because we want to write to this file. Finally, let's change the print statement to a write function to update our newly created file. Remember to close the file when you're done. At this point, our code should produce a file called passfile.txt that stores all the p's. With our code executed, let's go ahead and navigate to our current working directory. Great, our passfile.txt now exists. Let's go ahead and open it and check if it only contains passes. Nice, our code is working as expected. Adding on, let's go ahead and create another file to store the fails. All we need to do is duplicate the previous steps. First, let's create the file. Then, adding some new logic, I'll write to it. And the last step, let's make sure we close our file. At this point, our code should create two files. One that tracks people who passed, and one that contains people who failed. Let's go ahead and check if this is the case. Now, if I again navigate back to my current working directory, we can see now both the pass and the fail file exist. Let's go ahead and check out the fail file. As expected, this file only contains the f tags, so it looks like our program worked correctly. And with that, you've learned the basics of file I/O. Terminal and command prompt are powerful programs that provide command line interfaces with the ability to manipulate their respective operating systems. These tools can accomplish anything the graphical interface can with just a few keystrokes in the command line. To give our scripts access to these tools, let's learn how to run terminal commands in Python. To demonstrate this concept, we'll be executing external Python scripts using commands from the command line. To begin, let's create a dummy Python script that prints hello world to the console. Let's go ahead and save the script and call it example.py. Next, create a new file to house our automated terminal logic. I'll go ahead and save this file as script.py. To implement automating terminal commands with Python, we'll be using the subprocess library. Subprocess is a library that allows our Python script to interact with a command line interface or shell. The subprocess library contains many functions that can run terminal commands, but the one I'll be working with is the check call function. The perk of the check call function is it runs an executable in terminal and waits until the process has finished before continuing our script. To demo the functionality, I'm going to create a loop in which we invoke the dummy Python script in each iteration. The parameters of the check call function depend on what we want to execute in the command line, as each element in the list represents an argument in that command. Since we're trying to run our example.py script, our list contains python3 as the first element and example.py as the second, thus the command python3 example.py. At this point, our program should print hello world 5 times. Let's go ahead and check if this is the case. Great, and with that, you now know the basics of executing terminal commands in Python. In this scenario, we've been given this folder, Organize Me, which can be found in the exercise files for this course. As you can see, it contains a spectrum of file types, including the Python document I'll be working with today. So in hopes of better organizing our folder and reducing our frustration, let's create a script that generates new directories for each file type. Looking at my code, you can see I've already created a dictionary with 4 basic categories. The purpose of this dictionary is when we begin organizing our folders, we need to map each file type back to their overarching category. The current categories are documents, audio, videos, and images, although you can configure this however you want. So let's start the script by writing a function that returns a category based off the file suffix. Next, we'll write the logic of our function. We'll need to loop through all the items in the dictionary. And now we need a conditional. If the suffix is found, we should return that category. Basically, this function loops through the dictionary's items and returns the category in which the suffix exists. Just to make sure our pick directory is working, let's go ahead and test it. Let's try with the extension .pdf. And as expected, we get documents in our terminal. The next step is we need to loop through every item in the current working directory and get the file type so we can properly organize it. Let's create a function to house our logic. I'm going to call it organize directory. A good way to check what's in our current working directory is with the OS library function scandir. Scandir will grab every object in our folder and further our goal of grabbing each file's extension. To utilize this function, let's create a for loop that loops through all the files os.scandir returns. Additionally, when I grab the files, I should retrieve their paths, as this will help with manipulating the files later on. To get the path of each item, let's use the library pathlib and import the path function. Now it's time to isolate the suffix and determine what directory it should be organized into. The .suffix attribute returns the file extension. So now it's time to utilize our pick directory function. Let's pass in our suffix. Once we pass in the file type, directory should now equal the category the file belongs to. Let's cast it to a path to help with file movement. At this point, our function needs a conditional. If the directory the file maps to does not exist, then our script should create a new directory with that name. Moving the file into the map directory is independent of the if statement's outcome and should happen in both scenarios. So let's put it outside the if statement. This line allows us to move our file into the directory by changing the file path to join with the directory's path. Finally, we need some precautionary measures. First, I'll have the function skip if the item is a directory. Second, let's have our pick directory function return a misc category if the file type doesn't exist in our current dictionary. Before running the code, make sure your program is saved within the directory that needs organizing. In this case, the directory is organize.me. If we ls, you should see 5 different file types which fall into each of our dictionary's categories. Time to test our program. If I ls now, you can see I've created 5 new directories: audio, documents, images, misc, and videos. Let's go ahead and navigate there with our OS. As you can see, each directory has now organized its proper type. And with that, you now have the power to organize directories with Python. What is web scraping? Well, web scraping is a popular tool that many professionals use to gather data online because it offers an inexpensive alternative to the traditional means of extracting information. With the bountiful amounts of data online, it's essential you learn the tools to compile your own data cheaply and efficiently for whatever purpose. This sounds great, but how does it work? Well, there's only 3 basic steps of web scraping. First, they're sending a GET query to the website. This returns an HTML-based document containing all of the website's information, and thus setting us up for our next step, parsing. At this point, we parse the HTML document, making it more navigable and giving way for the final step, extracting the data we actually want. At this point, we can isolate the data we actually need from the website and store it in whatever format we like. Don't worry if this process sounds confusing for now, as we'll cover each step again in the coding portion of this series. Alright, let's get you set up. The critical libraries I like to use for web scraping in Python are Beautiful Soup, LXML, and Requests. Again, don't worry if you've never heard of any of these libraries, as it is not a prerequisite for this course. So, go ahead and open up your terminal and use your package installer to install each. The first library is Requests and is used for creating the GET query. The next library is LXML, which is used for processing the HTML. Also, it works with our final library, Beautiful Soup, to create a parsed and navigable HTML document. Once your libraries are properly set up, we're ready to begin coding. I'm here on a website called Quotes to Scrape, and let's say we want to compile all the quotes, their authors, and the tags associated with each quote from this page. Let's start by taking a look at how the website is structured. I'm going to open up the Chrome Inspector tool, and this displays an HTML document that creates the web page. To do this, go ahead and right-click and click Inspect. All websites have this component, which makes our job of scraping specific data a lot easier. This HTML document holds every piece of information that is visible on our page, meaning our quotes are hidden somewhere in this jumble of HTML. We just gotta find them. So in order to get this information to our Python script, we'll need to create a GET query. So to do that, I'll first copy the website's address and save it as a variable. Next, let's import the libraries we'll be using. The request library houses the GET function, and which we'll be using to ping the web address. This process returns a response containing the source code from the website. I like to think of this step as creating a connection with the URL, and as a response, getting back a copy of the website's HTML document. So let's go ahead and actually create the request. So with that done, the next piece of the puzzle is to parse the HTML document. And for this, we'll use Beautiful Soup and LXML. These programs work in Unity to create a navigable object that we can use to isolate specific data we actually want from the website. In this line, we'll be parsing response's text attribute and letting Beautiful Soup know we want to use the LXML parser. Let's go ahead and print soup to verify our connection and see if our parser worked correctly. And as you can see, we now have a copy of Quotes to Scrape's HTML, and we can now begin isolating specific data. So what I have here is a very simple web scraper that has pulled up all the HTML from Quotes to Scrape. And now it's time to zone in on the specific data we're looking to capture. So how do we do that? Well, before we write our code, let's talk about HTML structures. If I head back to the website, I can go ahead and right-click on any quote and inspect it. This will bring me directly to the portion of HTML code that the quote is housed in. In this example, you can see the quote highlights whenever I hover the span class equals text line. This means that this specific quote is governed by this section of the HTML document. If I go ahead and navigate down to the next quote, we can see it has the exact same line. And herein lies why web scraping is so easy and useful. To grab all the quotes on this page, all we need to do is get every instance of the span class equals text line. So before I go any farther, I'm going to give some brief context on the HTML system and what this line means. HTML stands for Hypertext Markup Language and works by categorizing different elements of the HTML document with specific tags. Zooming out, HTML has many different tags, but a general skeleton layout involves three basic ones: an HTML, a head, and a body. These help organize the HTML document. In our case, specifically for web scraping, we'll be mostly focused on the information within the body tag. So pivoting to our example, if we go ahead and inspect a quote again, we can see that most of the information is comprised within the span and div tags. These tags are usually used for sectioning pieces of information. Additionally, most modern websites partner these tags with a CSS document, which is defined by the class attribute. In our case, class equals text. And there you have it. That's about all the HTML we need to know to scrape simple websites. When it comes to your HTML document, there's a lot of information, and it may seem like we have to write a lot of code to grab the data we want. But actually, Beautiful Soup makes it possible to do this in a single line of code. In our example, by searching for all the elements with the span tag and the class text, we're able to obtain just the quote information. The function we'll use is the findAll function, which hones in on the tag and class we specify. Quotes now contains a list of all the elements on the HTML website with the tag span and the class text. Let's go ahead and print this variable. As you can see, we have the text property for each element, but also some extra HTML information. From here, let's try removing the HTML. We do that by just printing the text property. I'll go ahead and create a loop to print each quote. Great. As you can see, we've successfully scraped every quote from the website. But we want more than just the quotes. We also want the authors. So doing something very similar to before, let's go ahead and grab the authors' names using the findAll function. If we go ahead and inspect the authors, we can see their names are the text property within the small tag and the class author. Since each quote has one singular corresponding author, we can alter the for loop slightly to print out the author's names after their quotes. Great, and as you can see, we're now successfully scraping both the authors and the quotes. The final piece of our task is getting the tags for each quote. Using the same methodology as before, let's inspect the tags and see where they are in the HTML document. Well, it looks like each tag is contained with the A tag and the class tag. Moreover, each quote can have multiple tags, so maybe grabbing this element isn't the best option. If we use the findAll function on this section, we won't be able to determine where Albert Einstein's tags end and where J.K. Rowling's tags begin, because there's more than one per quote. To solve our problem, I'll recommend maybe going a step broader. Instead of grabbing these sections, let's grab the div tag and class tags section. Each quote only has one tags class, making this fit nicely with our existing loop. Now that the search has been narrowed down, we can just grab each quote's set of tags by using another findAll function. But instead of using the findAll on the entire soup, we'll just be using it on our tags variable. This is where we'll use the A tag and the class tag to zone in. Finally, let's iterate through all the individual quote tags and print out their text attributes. Let's go ahead and run our code and see if our implementation works. And look at that. Those are our quotes, followed by the author, and then followed by the tags. Our problem is solved, and you've now begun your journey to the world of web scraping. Let's talk about web scraping data on multiple pages. This is an especially common task in web scraping, as data is rarely contained within a single page. Online retailers, for instance, typically like to use multi-page setups, as they can offer more products than the traditional single-page websites. To help us practice this technique, we'll be utilizing this amazing resource created by Michael Yen, the Scraping Club. Here, you can practice many different scraping challenges, but our goal today is to scrape multiple pages. So I'll start by selecting exercise 3. This example presents a sample e-commerce store. And we can see by the pagination here at the bottom of the site that all items cover multiple pages. Before we dive into moving between pages with Python, let's set up a single page web scraper and build from there. So, to start, I'll copy the URL and open up your Python document and let's get started. I'll start by creating a request to the website and then parsing the response. Next, I'll inspect the items to see what tags and classes I need to search for. So let's go ahead and open up the inspector tool. For this example, it seems each item's price and name is housed within the div tag in this class, column, large, for, column, medium, and so on. So let's go ahead and use the find all function to grab them. Heading back to the Python document, now that we got the outer shells for each item, let's iterate through each and grab the text properties. It looks like the name is sectioned by this line, with the tag h4 and class card title. And the price seems to just be part of the h5 tag. So if we grab that, we should be good to go. Let's add a fancy print statement and test our code. Nice, we're getting our data now. But it also looks like we're getting an extra new line character from the item name. Let me patch that real quick. Let's try running our code again. Nice, everything is looking correctly formatted. Now we're ready to take our basic script and evolve it to handle multiple pages. I have a single page web scraper set up. And now it's time to take our program to the next level with multi-page scraping. To do this, let's navigate back to the website and use the Chrome Inspector tool to figure out how to navigate the pages. If I head to the bottom and inspect the page choosing element, we can see the links to the pages are contained within this property, href, or hypertext reference, meaning clicking this value would navigate us to the next page, or in this case, page 2. So, the plan going forward. If I store all these links in a list, we can create a new request to each URL and then use our existing scraper to get the data. If we narrow our soup to the pagination class, then we can iterate through each instance of the tag A in the class pagelink and grab the href attribute. There's just one caveat. This list would also contain the link to the next page. You can see when I hover over this href, the next button highlights. And if I were to scrape this link, I would create duplicate data because it references the same page as page 2, because we're on page 1. To proof this, we can grab the text property of each page link and try converting that value to an integer. If it doesn't work, we know it's either the previous or next page because we can't convert words to integers, and thus we can exclude them from our URL list. So, to begin, let's grab the pagination line and also create a list to hold our URLs. So now, let's use another find function to grab all the individual links. Now, let's iterate through all the page link elements and try converting their text to integers, and if we can, let's copy their links. So now we need a statement to check if the link's text property can be converted to a digit. At this point, pagenum will equal none if the value of the text property is next or previous, or it'll just be casted to an integer if it's one of the values of 1, 2, 3, so on. The next step, we should check if page number does not equal none. If this is the case, we should go ahead and grab the href attribute and append it to our URLs list. If I print the variable URLs, it should only print integer ones now and exclude the next and previous URLs from our list. Let's go ahead and test that. Now, as you can see, we're now getting the links to each page. So, the final process should consist of looping through each of the URLs in our list, adding it to our existing base URL, and then creating a new request and scraping the page. For the logic, we can just use our existing scraper. If I go ahead and copy and paste this chunk, our scraper should now scrape every single web page. Let's test this. Save our program, head to terminal, and run our code. Great, this is the correct output. However, our count variable is getting reset in every URL. That's why we keep looping from 1 to 9. Let's go ahead and move that outside the for loop. Let's try running our code one more time. Great, now you can see we're grabbing 54 different items. So now you've figured out how to navigate pages in web scraping. Enjoy the added benefit of scraping any of your favorite sites for huge datasets. So why automate web browsing? Well, there's really just two main purposes. The first and more prominent reason is to test website functionality. Automating testing decreases the cost and time while also providing a means of round-the-clock testing. Additionally, it makes cross-browser proofing easier. The second and less discussed application is botting processes online. Botting is defined as a piece of software that executes commands or performs routine tasks without the user's intervention. And this can be applied to any repetitive task online. For example, let's say you order takeout every day from a website. Well, instead of manually filling out the form each time, you can instead script the entire process. Or perhaps logging into a certain website or email becomes a tedious task. Just script it. Any repetitive online task can now be optimized by creating a Python script. However, these examples just represent benevolent botting tasks. Conversely, this tool can be used for much more nefarious purposes. One of the biggest issues is botting limited quantity items. Tickets to shows or exclusive merchandise are good examples. Normally, the checkout process appears fair, as everyone must go through similar steps before a product sells out. But automation creates an unfair arena. Scripts can navigate websites significantly faster than humans, and moreover, scripts can execute hundreds, if not thousands of requests at once, nearly guaranteeing the process. Consequently, this makes botting notorious for only being used for exploits. But as discussed before, there are positive purposes. Alright, with that disclaimer out of the way, let's get you set up. We'll be using the Selenium library to help us interact with the web. Go ahead and install it. Additionally, Selenium interfaces with the internet by using a WebDriver, which is a browser that Selenium can use to automate web processes. The two ones I recommend using are Chrome Driver, which runs Google Chrome, or Gecko Driver, which runs Firefox. So, select whichever browser you feel more comfortable with, and then use a package installer to download either one of the drivers. You don't need both. I'll be using Chrome Driver and downloading it with the Homebrew package installer. It's important to note that Homebrew is a macOS exclusive package installer. If you're on PC, you'll need to manually install Chrome Driver or Gecko Driver from this site. With that set up, we're ready to begin coding. In this video, I'll be covering how to open a browser and the basics of how Selenium interacts with the web. To test our code, we'll be using this website, seleniumeasy.com. Here we can practice implementing some of the basic Selenium functions. I'll be working with this specific test case, which can be found by clicking the input forms and then simple form demo. So, go ahead and copy this URL and let's get started. I'll start by importing the WebDriver module from Selenium. WebDriver is basically a browser that Selenium will use to interact with the web. To use it, the first step is to initialize our WebDriver. So to do that, we'll do driver equals WebDriver.Chrome. If you installed Gecko Driver, replace Chrome with Firefox. Next, we need to get the URL. To do this, do driver.get and then paste our URL. At this point, our code should open up a browser and then change the URL to the one we have here. Let's quickly run our code to check if this is indeed the case and to ensure our dependencies are properly installed. Great, looks like everything is working properly. With that accomplished, let's discuss interacting with this page. Looking around, it seems there's a couple fields we can interact with. The first is this message board or single input field. The second is the two input fields. For now, let's just try writing the classic hello world line in this single input field. To get a message to display, we need to first type a string. Then we need to click the show message button. Translating this to Python, the first step is to tell our program what element we want to interact with. The easiest way to do this is use the inspector tool. In our case, we want to type a message into the enter message field. So, go ahead and inspect it. When I hover this line, the message box highlights, meaning our field is correct. Go ahead and right-click, copy, and copy XPath. The XPath is element specific and allows Selenium to find our HTML item. Heading back to our Python document, we can grab this specific element by using the function findElementByXpath. Go ahead and paste the XPath. Now that we've specified the element, we can go ahead and try to interact with it. Since this is an input field, we'll need to pass a string to it, which can be done with the sendKeys method. Let's go ahead and type in hello world. Now we'll need to click the show message button. Like before, let's grab the element by copying the XPath. Go ahead and right click on the button, inspect, right click again, copy, and copy XPath. To click the button, we can just use Selenium's click function. Alright, let's run our code and see our progress. You can see we've successfully accomplished our first task. Next up, let's try interacting with the two input fields. Similarly to the first process, we can just send keys to the two input fields and then click the Get Total button. So, go ahead and inspect the first input field and then copy the XPath. Like before, let's create a field for it and send keys. For now, let's just pass in 10. Let's repeat that process with the next addition field. Go ahead and right click, inspect, and copy XPath. This time let's send 11. Now it's time to grab the Get Total button. Once more, let's go ahead and right click, inspect, and copy XPath. This time we'll need to use the click function. Okay, let's run this and check our implementation. Zooming in, you can see we not only completed the first input field, but also the two input fields below it. We entered 10 and 11, and the answer was 21. Great job, we've created a simple bot with Selenium. Most actions performed with Selenium can be accomplished with a single function. So, I'd like to take a look at a more challenging WebDriver action, the drag and drop. As you know, this action consists of 3 basic steps. First, an object or text must be selected. Then, it must be dragged to the desired area, and finally dropped into place. So how do we do this with coding? Well, we'll need a source element that we want to drag, and a destination element we want to drop to. To demo our code, we'll be using this DHTML goodies web page, which will act as a practice ground for our script. So, go ahead and pause the video and copy down the URL. Examining the website, you can see they've designed a simple interface to practice drag and dropping. So let's go ahead and get started. Copy the URL and then open up a Python document. I'll start by creating a WebDriver. Also, for viewing purposes, I'm going to maximize the window. Next up, let's open up the URL. Now it's time to specify our source and destination elements. The best way to do this is once again by grabbing their XPaths. The capitals on the left are the source elements, as these represent the objects we want to move. Let's start by specifying our source element in our code. Pull up the inspector tool on the Washington box and then copy the element's XPath. Next, we'll need to specify which destination element we want. In this case, our destination is the United States box on the right. Go ahead and copy its XPath and specify the element in your code. Now it's time to create the action. To implement a drag and drop in Selenium, I'll have to add an additional library, action chains. Action chains extend Selenium by allowing the WebDriver to perform more complex tasks, like drag and dropping. When methods are called for actions on the actions chains object, the actions are stored in a queue. Let's go ahead and call our drag and drop function on the actions object. The first parameter is our source, and the second one is our destination. To execute actions on the actions object, we'll call perform, which then fires the events in the order they were queued. Now it's time to test our code. As you can see, we're now capable of dragging and dropping objects with our WebDriver. Let's talk about wait functions with Selenium. What are they and why you need them? So, the problem with scripting modern day websites is many of them use asynchronous techniques like AJAX to load their web pages. This method allows web servers to update parts of their web page without reloading the entire thing. Because of this, they're able to create fast loading and dynamic web pages. However, this becomes a problem when our Selenium WebDriver tries to locate a web element before it's loaded. This will raise an exception with our script and our program will not work. And this transitions us into why we need wait functions. Wait functions can add crucial time intervals in between actions performed, thus allowing the WebDriver to wait until an element is loaded before it interacts with it. Selenium offers two types of waits, explicit and implicit. Explicit waits, when paired with a condition, will wait until that condition is satisfied before executing. On the other hand, implicit waits will instead try to pull the DOM for a certain amount of time until the element is available. Great, so now you know some context about wait functions. It's time to show you them in action. To practice implementing wait functions, we'll be taking a look at the web page Google Earth, which uses AJAX to load its elements. Navigating to their website, you can see when I initially load the web page, the top banner appears slightly after the rest of the page is loaded in. Let's watch that one more time. Let's say we want to click the Launch Earth in Chrome button. If we used normal ways of grabbing the element, at this point we would get an exception, as the element doesn't exist when the web page first loads in. Let's work around that by using an explicit wait. Heading back to the Python document, let's go ahead and import the necessary libraries. Like before, let's import WebDriver. And additionally, I'll be using a few new extensions. The first is Buy. The next is WebDriver wait. And the last is expected conditions. For now, just know that these modules will help me implement the explicit wait function. Alright, let's create a WebDriver and pass in our URL. Now it's time to institute the wait. The way to do this is two-step. First, I'll create an explicit wait using the WebDriver wait function. This function will throw an exception after 10 seconds if the condition we make is not satisfied. So now we must create a condition for the explicit wait. To implement this, I can pair it with the expected conditions module to make our program wait until a certain action can be completed. In this case, the program should wait until the Launch Earth in Chrome button becomes clickable. So let's go ahead and grab the XPath of the button and implement this idea. Go ahead and inspect the button, and then copy the XPath. Now it's time to implement the condition. Let's start by creating a button and set it equal to wait.until EC, our condition, which in this case is element to be clickable, Now, our program will not throw an exception, as this line waits until the specified XPath element is clickable. We should be able to interact with this element without any problems. Let's go ahead and add the click function. Time to test our code. Great, our program clicked on the button. So there you have it. That's how to use explicit waits with Selenium. Have you ever wondered how so many technologies are packed into applications or web pages? Or rephrased, how do developers for these softwares have enough time to code all this functionality into their programs? Well, the simple answer is they don't. Their secret is API calls. APIs enable developers to create repetitive but highly sophisticated software with merely a couple of lines. This is possible because APIs act as pre-packaged functionality that developers can drop into their code. A great example are apps that use map-based location. Almost all these softwares did not build their own map technology. This would be a costly endeavor for any small company. So rather than reinventing the wheel, they most likely used a pre-built map API, like Google's. This is because the functionality is similar or better than map technology they could produce, as Google specializes in this field. And additionally, there's no overhead cost of using an API. So how do APIs work? Well, basically, APIs act as an intermediary for two pieces of software, hence their name, Application Programming Interface. Implementing APIs into code requires two steps. First, the script must create a GET query with parameters that is sent to the API. To construct the GET query, we'll be using Python's request library. This can be installed using your pip installer. After the request is sent, the API will return a response that is typically encoded in a JSON format. JSON is the primary format in which data is passed back and forth to APIs, and most API servers will send their responses in JSON format. So armed with that context, you're now ready to dive into the ocean that is APIs. Let's check out the first step of using APIs, creating the request. To practice, we'll be using this free API on upsitemdb.com. This software translates barcodes into a whole host of information, including the product's name and brand. To see what an example API call should look like, let's go ahead and use their online GUI that I've pulled up here. To demo, I'll just use a LaCroix can barcode. This is a lot of information to break down, but for now, let's just focus on the request URL line at the top. This line contains two factors, the base URL, or everything preceding the question mark, and the parameters of the API call, or everything after the question mark. The base URL is independent of our parameters and will be the same for any barcode we look up. However, on the other hand, the parameters are specific to this barcode search. This may sound complex, but this breaks down very simply into code. Let me show you. Let's start by constructing the base URL for our API call. Just go ahead and copy the entire URL preceding the question mark. Now I'll need to construct the parameters for the API call. This is done by making a Python dictionary. To structure this dictionary, let's take a look at the information after the question mark. From the highlighted text, you can see UPC is equal to our LaCroix barcode. So in our dictionary, UPC should be the key and our barcode should be the value. With the basis covered, it's time to actually invoke the API call. To do this, I'll use the request library, which allows us to send our GET query containing the parameters and our base URL. To make sure our API request was properly constructed, let's go ahead and print out its responses URL attribute. Comparing to the demos, you can see we've made an exact match. And with that, you've constructed your first request to an API. So I've built the API request to the upsitemdb interface. And now it's time to work with the API's response. Let's begin by grabbing the response's content attribute, as this will contain the content sent back from the website's interface. Recall that APIs transfer information in the form of JSON documents, which is not a native data structure in Python. So to make the response more navigable, let's go ahead and import a library called JSON. This will help as JSON has a function called loads that converts JSON documents into dictionaries, thus making the API's response much more Python friendly. To confirm that the function has worked correctly, I'll go ahead and check the info's data type as well as print it to the console. Great, our suspicions are confirmed as the type is indeed a dictionary, so we're now ready to isolate the specific data. Looking back at the online GUI, let's try isolating the item's name as well as the brand. Glancing at their interface, The way to our information looks three-step. First, we'll need to hone in on the items key of the dictionary, as this contains the brand and name information. Zooming in, it looks like we'll need to access the first and only element of the item's dictionary value. At this point, we've reached another dictionary, so we can simply grab the dictionary's values for the key's title and brand. To see if our implementation is correct, I'll print these values. Great, those match up perfectly with the demo's API call. So with that set, it's time to show the functionality of our 14-line script. Let's choose another barcode to demonstrate the flexibility of our code. This time I've picked the barcode of a green tea drink. Let's go ahead and run our script to see if our code works independent of the barcode. And look at that, we've created a simple program that converts barcodes into their corresponding item name and brand. API developers like to inspect who's calling their software, and thus many APIs use keys to mandate access. Making keys mandatory for an API allows the developer to select who's using their software, as well as monitor how many calls each client makes. This is important as there's an overhead cost for the API developer who has to constantly update their interface's software. By monitoring their clients' calls, they can appropriately price plans for each client's needs. So what does this mean on our end? Well, some APIs are locked behind accounts or paywalls, meaning as software developers, we'll need to make an account with the organization hosting the API to obtain keys for access. For example, in this demo, I'll be using OpenWeatherMap's API. I've already gone ahead and created a free account, which gives me access to these base features. Additionally, as you can see, they've given me a unique API key for my account that I must use when I construct my requests. If you'd like to follow along for this example, you'll also need to create your own account and use your own uniquely generated key. Heading to their documentation for 3-hour, 5-day forecasts, we can see how the API is called under the API call header. Let's go ahead and copy what's left of the question mark as our base URL. Additionally, make sure to attach the HTTP protocol to the front of the URL. Next, we'll need to construct the parameters for the API call. In this scenario, the API call needs a city name and a country code. I'll choose the city Seattle with the country code US. To make sure the interface responds to us, we'll need to attach our API key with our GET request. To do this, we'll package the API key with the parameters. Looking at their documentation, it looks like they want to use the API key paired with the dictionary key APP-ID. Note that the dictionary key APP-ID is specific to this API's documentation, and that if you want to use a different API, this value may be something else. Now it's time to use our uniquely generated key. Go ahead and copy it and add it to the parameters. Now let's go ahead and create the request. To verify if our implementation worked properly, I'll go ahead and print the content of the response. Great, we're now getting the JSON document from the interface. And with that, we've now seen how to interact with APIs that require keys. Let's talk briefly about linking API calls. This strategy revolves around chaining information between APIs to generate complex processes with minimal coding. With the countless APIs in the market today, creating such a software is more feasible than ever. Here I've pulled up rapidapi.com, which is a marketplace that contains hundreds of free APIs for software developers. This can be a creative playground for cool projects. There's APIs for text messaging, weather info, recipes, text analysis, and facial recognition. So for example, by linking APIs, we could create a program that could receive text using Twilio's API that contained a food article Then reduce the article to just key ingredient names with a text analysis API. And finally, generate a recipe based off the initial article we texted in using a food recipe API. This complex process can be generated with just 3 API calls, which we've discovered is quite a simple process. So, hopefully armed with that context, you can venture forth and create your own complex processes using multiple APIs.